Hello everyone, I am Dilani Dassanayake and I am talking to you from a beautiful island in the Indian Ocean, Sri Lanka. Today, my presentation is about environmental loss evaluation approach developed for the coastal flood risk analysis. First, I will present what motivated me to conduct this research study. Then I will show the new approach I proposed for the evaluation of environmental losses. Further, I will provide the details about the exemplary application of the proposed approach. Finally, I will conclude my presentation with some remarks. Motivation. Coastal flooding is one of the most devastating natural disasters which occurred in the recent past, and it further increases due to the effects of sea level rise and storm surges associated with climate change. Therefore, the development of methods for the estimation of coastal flood risk has become an urgent need for the identification and implementation of proper coastal protection measures. Flood risk is generally defined as the combination of the probability of a flood event and of the potential adverse consequences for human health, the environment, cultural heritage, and economic activities. Flood losses might be divided into two categories, namely tangible and intangible, depending on whether or not the losses can be assessed in monetary values. Tangible losses are evaluated in monetary values and hence commonly incorporated in flood risk analysis. On the other hand, intangible losses, that is mainly social and environmental losses, are not or only partially incorporated in flood risk analysis due to the lack of appropriate evaluation and integration methods. So, I have proposed new approaches for the evaluation of both social and environmental losses, but in this presentation, I will cover only the approach I developed for the environmental losses. This figure shows you the overall approach proposed for the evaluation of environmental losses, which is based on the ecosystem services approach. The method consists of two steps. First, identification of ecosystems and their services, and then the estimation of changes, in this case losses, on ecosystems and their services. First, the ecosystems available in the considered area should be clearly identified using land use data, and then the services provided by each ecosystem should also be identified. Using flood data and damage modeling, the losses in ecosystems due to the expected flooding should be due to the time limitation, I will only show how to estimate the damages of beach dune ecosystem using this new approach. First, the services provided by beach dune ecosystem are identified. In this case, two major services are considered: coastal protection as a regulation service and recreation and tourism as the cultural service. Beach and dune ecosystem damages are estimated using XBeach modeling. XBeach provides the changes of dune profiles for the given wave conditions. By the comparison of the pre-storm and post-storm dune profiles, the beach dune damages can be categorized into three main levels. First, the beach erosion only. Second, beach and dune erosion. Third, beach erosion and dune overwash and collapse. Based on these three levels of beach and dune damages, the loss of ecosystem services provided by beach dune ecosystem can be estimated using an ecosystem services damage assessment table. This is the ecosystem services damage assessment table. I call it ESDA table, which I developed for the beach dune ecosystem for the considered two services. The first damage level, that is only beach erosion, has a slight effect on the regulation service and a short-term loss on cultural service, and therefore the overall ecosystem service damage level is low. The second damage level, which is both beach and dune erosion, may affect the regulation service into some extent, as it still can provide the protection service for minor storms once it's stabilized. The cultural service may also affect, as it takes time for the eroded dune to be stabilized. Therefore, overall damage level will be medium. The third damage level is beach erosion and dune collapse. Here, the coastal protection service is significantly affected. In the case of cultural service, a major change of landscape may provide cultural services into some extent, but a reduction of beach dune area may lead to a long-term cultural loss. Therefore, overall ecosystem services damage level is high. Once damages of all ecosystems and their services are identified, the overall environmental damage can be estimated as shown in this slide. Here, an imaginary area with 3 ecosystems is considered, and by developing similar methods to estimate the damages to ecosystem services, the levels of ecosystem services damages are estimated. Then the environmental losses are represented by the ecosystem services damage levels. I exemplarily applied the proposed method to estimate the beach dune ecosystem services losses in Sylt, Germany. Here I selected 4 distinct dune profiles along the west coast of Holland to investigate the damages due to an estimated storm surge using XBeach 1D modeling. XBeach simulations provided these dune profiles. As you can see, the initial profiles are shown in blue color and the final profiles are in red color. Here, the dune profiles 1 to 3 undergo dune erosion only, and the profile 4 experiences dune collapse. So based on the XBeach results and the ecosystem services damage assessment table, 1 to 3 dune profiles undergo ecosystem service damage level of medium, and the profile 4 undergoes a damage level of high. In this exemplary application, I only used XBeach 1D modeling to illustrate the new approach. So, I will conclude my presentation. The new method is proposed for the evaluation of environmental losses and exemplarily applied for the estimation of ecosystem services damages of beaches and dunes in Hornum Sylt. Ecosystem services damage assessment table, that is ESDA table, is developed for the estimation of ecosystem damages based on the damages of ecosystems. In the example of beach dune ecosystem, the dune erosion and damage may considerably affect the coastal protection service. but the change of dune landscape may not significantly affect tourism in long term. Therefore, it is essential to consider all ecosystem services provided by the ecosystem and then identify the most dominant type of ecosystem service loss due to the changes of ecosystem in order to get the overall environmental damage. So this is the end of my presentation. Thank you very much.